Hello and welcome to lesson 6 in this series. Today we're going to be talking about representing images. In the last lesson we looked at characters, but today we're going to be looking at images. So things like how images are represented as a series of pixels. We're going to be talking about metadata. We'll discuss the effect of color depth and resolution on our images. Images can be made up of blocks called pixels. Pixel, the word itself, is just short for picture element. A simple image can be made up of black or white blocks, or black or white pixels. Binary numbers can represent these black and white blocks using 1 for black and 0 for white. So 1 bit per pixel. So if you take a look at this image over here, we've got a nice smiley face. And that smiley face can be stored in the computer as a series of binary numbers. 1 represents the black, 0 represents the white pixels. This image uses 8 bits or 1 byte to represent each row. The image itself is just 8 pixels wide by 8 pixels high. As each row is represented by 1 byte, this image requires 8 bytes or 64 bits to store it. Most images are not black and white, however. We need to use more bits per pixel to represent more colors. 2 bits per pixel gives us a total of 4 colors. 4 bits per pixel gives us 16. 8 bits, 256. 16 bits gets us over 65,000 colors. 24 bits raises that up to 16 million colors. And if we use 32 bits per pixel, then we can get over 4 billion colors. Typically, we use 24 bits per pixel to give us what we call true color, which is natural lifelike color. And if you have a look at these images in the bottom, you can see there's quite a bit of difference between the 16 color image and the 16 million color image. The number of bits used to represent the colors is often referred to as the color depth, or sometimes the bit depth of an image. The more colors we have available, the better the representation of the image. However, the more colors we have, the more data we need to store for each pixel, and the greater the storage requirements. Higher resolution images also have more pixels to store, further increasing the amount of data that we need to store somewhere on our hard drive or SSD. So let's just have a bit of a refresher on calculating storage for images. Remember, image size is your color depth times the image height times the image width. The last two, of course, in pixels. So if you look at those tree frog images, if the resolution is 200 by 200, then the 4-bit image on the right would use 4 times 200 times 200 equals 160,000 bits. If we then divide that by 8 to convert to bytes, then divide it by 1,000 to convert to kilobytes, we get 20 kilobytes in total. Whereas the 24-bit image uses 24 times 200 times 200, which is 960,000 bits in total. And again, we can convert that through to 120 kilobytes. So you can see there's quite a bit of difference in the image size by increasing the amount of color. If we were also to increase the amount of resolution, maybe 400 by 400 or 1,000 by 1,000, you can see we'd be using much greater amounts of pixels and you needing a lot more storage space to store all that on our computer. This is why we often have to reduce color depth or resolution in order to save storage space or reduce bandwidth when sending images online. In order to represent images exactly and accurately, the computer needs to know exactly how to interpret these numbers. This information about the image is what we call metadata, and we looked at that briefly in a previous lesson. Metadata often includes information such as the number of bits per pixel, the color depth, the size of the image in bits, the resolution of the image in dots per inch, DPI, and much more. In summary, images can be made up of a series of blocks called pixels. We can use binary to represent these pixels. Color depth is the number of bits used to represent each pixel. The greater the number of bits, the greater the number of colors that we can represent in each pixel. Resolution is the number of pixels in an image. If we increase the color depth and the resolution of an image, we increase the quality of that image, but we also increase the file size. Conversely, if we decrease the color depth and the resolution, we decrease the quality of the image, but we also decrease the file size. Well, I hope that was all useful for you. We will continue looking at how we represent data for computers in the next lesson when we look at sound.